Hello everyone, I hope you're doing well. So in this video, we're going to discuss Geeks for Geeks problem of the day, and today's problem is valid compressed string and it is of medium level. So I believe that it is more on the easier side of the medium difficulty range, and I hope that if you have not solved this problem yet, you will be able to understand this problem very easily. So let us quickly start with the problem statement. Now this problem says that we have been given two strings S and T, where S is the normal string and T is the compressed string. Then we have been explained the compression mechanism, and it says that we can arbitrarily delete 0 or more characters and replace them with a deleted character count. And at the end we just have to print 1 if T is a valid compressed string of S and 0 if it is not a valid compressed string of S. Now let me just explain you with the sample test case. So this is a sample test case that we have been given. So the initial string is Geeks for Geeks. So Geeks for Geeks. You can ignore the spaces. The spaces are not there in the actual string, right? So now the compressed string is G7 G3S. So we just have to match the first character. It is G in both of the strings. Then we have 7. It means that we have to skip 7 characters. So 1, 2, 3, 4, 5, 6, 7. Then again we have G, and we have G here, and then we have 3 here. So we have to skip 3 characters. 1, 2, 3. And then we have S, and then we have S here. So it is a valid string, so we have to return 1. If it was not a valid string, we had to return 0, right? So this is a very simple problem. Now a few key observations before you start solving the problem. The first and the foremost important observation is that if you are at any position, if you are at current position I in string S and you are at position J in string T, so this is S and T, right? If the ith position in string S is not a digit and the jth position in string T is not a digit, so it should be equal, right? Like in this particular example, G and G were equal, and again here G and G were equal, and at the end S and S were equal. So since they were not digit, they have to be equal, right? Now what if we encounter a digit like here 7, right? We encounter 7. So this was the first observation, important observation, and this is the second important observation. Second important thing is, whenever you encounter a digit, we can't just directly skip those number of digits. For example, if there is 7 here, we can't just skip 7 directly. For example, if it was a very long string and there were it was like this 78GS G78S. This was the compressed string. Whenever, as soon as we see 7, we cannot directly skip 7 characters. We have to wait and check further. For example, if I have encountered 7, I have to go forward and check whether the next element or next character is also a digit or not. If it is also a digit, I have to consider this whole thing as one single number, right? So for example, if it was 1, 2, 3, 4, 5, right, and then S. Now I can just directly skip one character or two character here, right? I have to consider this whole string and then take the whole number. So in this case, I have to skip 12,345 characters, right? So this is the second important thing. And I believe like this much information is enough to solve this particular question. There's nothing more you need to know about, and this is the only intuition you need to solve this particular question. So let me just quickly repeat this particular approach. Now we just know that if the current index is not a digit, they have to be equal in S and T, right? As soon as we encounter a digit, we don't have to directly skip those number of characters. We have to wait and check whether the subsequent digits are also digits or not, right? And then as soon as we finish encountering the digits, like we have completed all the digits, like here in this case we started from 1, then we 2, go to 3, 4, 5, and then we finally reach S. We have run out of digits in this case. So we make a stop here, the start is here, we take this number of characters and then skip it in the original string, right? And then again, the next character is not a digit, so we have to match it directly. So this is the whole logic. Now let me show you how to do it in the code. So there's some important things, that how will you skip and how will you make this whole string into a numeric format or an integer. So this problem is more on that part and less on the logic part. So let me show you the code now. So what I've done is I've initialized two variables I and j with 0, and the first and the foremost, the most important condition is I should be less than s dot size and j should be less than t dot size, right? So if we are traversing through any string, and then this condition is very important, right? So I have checked if the current element is a digit in t at the jth position, right? So using j I am traversing the t string, using I am traversing the s string, right? So I just check whether the jth character in the t string is a digit or not. If it is a digit, I just initialize my variable x with j plus 1. So what I'm essentially doing is, if I am at current position j, I'm initializing x with j plus 1, and I run a loop while x is less than t dot size and the character at the xth position of the t string is also a digit. So I'm just incrementing x. So for example, if I had this, right? So this is s, or let me just take a different character. This is g, right? So I started from 1. I found that this is a digit, so I started my variable x. So j was initially here, and I initialized my x from here, from the second position, right? So this is a digit, I move my x further. This is also a digit, I move my x further. This is also a digit, I move my x further. Again I move my x further, and finally my x reaches here, right? So it is now at g, and this is not a digit. So how will I calculate the size of this particular substring? I just have to do x minus j. Simple, right? So if I do x minus j, I'll get the size of the substring. Now I can get that particular substring 1, 2, 3, 4, 5 by doing t dot substring starting from j and of size, which I have already calculated here. So what it will do is, it will start t dot substring starting from j. So this is the starting index and this is the size. So you can directly also write x minus j here. So what it does is, it starts from j and then it goes like x minus j size. So it will go till here and store it in a string called small t, right? So I calculated this. Now I can convert this whole string into an integer using an inbuilt function called stoi. So what it does is, it converts any string into the corresponding integer value. So if it is written 1, 2, 3, 4, 5 in string, it will convert it into integer 12,345, right? Once I calculate that particular value in the integer, I can store in a variable called jump. So jump is the number of characters I have to skip in the string s. So what I do is, I just increment the value of I by jump. That means I'm skipping those many characters in the initial string s, and I'm updating the value of j as x, right? Because I have completed all these 1, 2, 3, 4, 5, and now my j should move to here, this position, right? So I'm updating the value of j as x. Once I do this, I just write continue so that I can re-enter the loop. Now if that jth character in the t string was not a digit, then I would have checked whether the ith character in s and jth character in t are equal or not. Because I already said, if it is not a digit, then they must be equal. If they both are characters, they must be equal, right? If they are not equal, I just return 0 right from here, right? Because right, they should be equal, otherwise it is not a valid compression. Now if this is also not satisfied, then I just increment I and j by 1. So when will this condition run? So this will run in a case like, for example, if I have this, let me just write the original thing, right? So this is the example. So in this case the t of j is not a digit, so this part will not run, right? And S of I is equals to T of J. They are equal. So this part will also not run. So what will essentially happen is J will move on here and I will move on here. So both of them will be just incremented by 1, right? So this is the logic here. Now after all those loops have been completed, I just check whether I dot size, I is equals to S dot size or not. So why am I doing this check? Because here when I incremented the jump, then there might be a case, for example, if the initial string was for, and I write here 10, right? So it means I have to jump 10 spaces, right? And I don't even have 10 spaces here, and it will the I will go to some arbitrary position here. So this is not a valid compression of this particular string for. So I just need to check whether I is equals to the s dot size or not. That means I should be just next to the character R. So I should be at this particular position for it to a valid compression. For example, if it was 3 here, then I would have been jumped by 3. So I initially was here, then it goes to this position 1, 2 and 3. It would be at this final position, right? So it should be just next to the last character and its position should be equal to s dot size. Now why are we not doing this for the j next? Because for j we are either incrementing it by 1 or we are just jumping to a position which is also a controlled variable x, right? If you see here, x is also controlled here with respect to t, but jump is not controlled with respect to the string s, right? That is why we have to check this condition for the ith index. Now if this is true, I return 1, otherwise I return false or 0, right? So this was the solution of today's problem of the day, valid compressed string. I hope you guys were able to understand the solution. If you guys were able to understand it, you can show your appreciation by clicking on the like button. And I've also observed that a lot of people who watch these videos have not subscribed yet. So you can also consider subscribing to this channel. It's always free and you can always unsubscribe later if you don't like the content. So now it's time to share this video with your friends. Until the next video drops, keep coding, stay safe, bye bye.